Okay, so hello students, welcome back. This is सुयश बाजपेयी here in front of you. तो स्टूडेंट्स, अभी तक हम लोगों ने जो लास्ट लेक्चर में देखा था वो बात करी थी हमने डिफरेंशिएशन की. वी हैव टॉक्ड अबाउट डिफरेंशिएशन एंड वी हैव टॉक्ड अबाउट इंटीग्रेशन. वी हैव टॉक्ड हाउ टू डिफरेंशिएट एंड हाउ टू इंटीग्रेट अ फंक्शन with respect to x. Okay, and integrate with respect to x. All right, we have seen some formula, then we have seen some tricks, and then we have solved some numericals based on that, right? So now today in this lecture we know how to integrate, how to differentiate a function, and how to integrate a general function, right? Clear, simple function, right? So now we will see in this lecture, we will see what is the physical meaning, okay, physical representation of integration and differentiation. Today we will talk about the physical, okay, the physical meaning, okay, meaning or representation of differentiation d by dx, okay, and integration means integration of dx. Clear? Means here you will have a function f that you have to differentiate, here you will have a function f that you have to integrate, right? That you have to differentiate, that you have to integrate, right? So let's see the physical meaning of differentiation first. Okay, it is very simple, students. You have to just focus here and you will get to know everything here, right? So the physical meaning of your differentiation is simply, it gives you, is simply what it give you, it will tell you something about the tangent. Okay, tangent. So what do you mean by tangent? Tangent means tan theta. All right, just check. Or you can say the slope. Clear? So this is what you mean by differentiation. For example, let me give you one example here, okay, that will make it very clear to you. Okay, suppose here you will have a y-axis and a x-axis, okay, and suppose here we have a curve. Okay, suppose here we have a curve like this. Okay, so suppose we have a point, x1, clear, and here we have y1 coordinates, right? And a point here which coordinates are simply here, suppose x2, and yeah, and you can say yes, y2 from here. All right, just check. So if you will join these 2 points, clear, if you will join these 2 points, this triangle, what do you mean by this triangle, right? You have to think now. Okay, so we have joined these 2 points, clear, and this angle is theta. Okay, so now this will become y2 minus y1, and this will become x2 minus x1, right? This, okay, so our y2 minus y1 by x2 minus x1 is nothing but delta y by delta x, right? Just check, all of you. So this will change to dy by dx. This will change to dy by dx if this delta x tends to 0. Okay, got it, students? Everyone, just check this, right? Means if this delta x tends to 0, means what will happen here in this case, these 2 points will come closer and closer and closer and meet somewhere here, right? Then the line will be this, the tangent, right? The line will become a tangent. Okay, and what this delta y by delta x will tell you here, this theta, if this is theta, then I can write, I am writing it by permanent marker. Okay, all right, students, just check, all of you. Clear? Yeah, if this angle is theta, so your tan theta is nothing but delta y by delta x. All right, just check, this is your delta y, and this is your delta x. Just check, all of you, right? So this is your tan theta here in this case, but this delta y by delta x, if limits delta x tends to 0, this will become dy by dx. Just check, all of you, right? Means if in figure I'll show this, clear? Then these 2 points will coincide. Okay, let me erase these two things. Okay, wait, yeah, let me erase this line. Okay, so the point delta x is very small, that these 2 points will come closer and closer and meet, right? So now the line become this. Okay, clear? So that's it. This is the line which is tangent to the curve, right? Which is tangent to the curve. Just check here, right? So now this line will become tangent, hence this dy by dx will give you the slope of the tangent. Okay, the slope of the tangent, right? The slope of the tangent at particular point. Suppose this is point your x comma y, so this will give you the slope of the tangent at x comma y, at that point. Okay, or you can say simply I am saying that at that point. Clear? Okay, students, so this is mean by your dy by dx. Clear? So it will give you not tangent, not slope, it will give you the slope of tangent, right? Finally, slope of tangent. So this is your differentiation means. Okay, this is your differentiation means, slope of a tangent. Let me make it more simple to you. So it is denoted by m, small m, right? You have studied in your 10th class mathematics. Okay, so this is slope, m is equals to tan theta is equals to dy by dx here in this case. So let me conclude that. So conclusion. Okay, conclusion, very simple. Okay, if we have, suppose, y as a function of x, clear, and we have differentiated this, clear, we found dy by dx, clear. So at some point x naught comma y naught, then this will give you the tangent, the slope of the tangent, the slope, this will give you m, which is nothing but the slope of the tangent on the curve. Okay, on the curve fx, clear, on the curve fx at x naught comma y naught point, right? Means if I'll tell you this graphically, then suppose this is your y-axis, this is your x-axis, and this is your function, suppose, right? Sorry, this is your function, suppose, right? This is y, this is x, clear? Then these are our 2 point. This is your x naught and this is your, suppose, y naught, clear? So differentiation dy by dx at x naught comma y naught will give you the tangent at this point. The tangent at this point will be like this, right? The slope of the tangent. So this is the tangent, and the slope means what angle will it make from x-axis. This is theta. This will be given by your dy by dx at x naught comma y naught, right? So I hope this thing is very much clear. Okay, in physics, if we'll talk in physics, then students, let me tell you, this is the physical meaning of differentiation. I hope this thing is very much clear to all of you. So this is your conclusion. This is your complete conclusion, what I have given here. All right, this is what you have to just note down by heart, right? Just remember by heart, right? So this part is your conclusion part. Okay, clear, students? Just check, all of you. All right, now let me go to the physics again. So if you will have xt graph, okay, now I am telling you some basic information that you have to learn, right? In your xt curve means this, suppose this is your xt curve, this is y-axis, clear? Sorry, this is y-axis, this is x-axis, right? So in y-axis you will have x, in x-axis you will have time, then slope of this xt graph will give you velocity, clear? Slope will give you velocity. Y will give you what? Slope will give you velocity. Why? Because slope of this xt graph is dx by dt. Okay, the slope of, from here, the slope of yx graph is what? Is simply dy by dx, right? The slope of yx graph is, xy curve is dy by dx. The slope is xt graph is dx by dt, and dx by dt is nothing but velocity, right? So just remember this. Slope of xt graph is velocity. What is the slope of vt graph? That is dv by dt. Check, all of you. So it is acceleration. Clear? The slope of xt graph is dx by dt. So this what you have to learn, right? This is the physical meaning of differentiation. Okay, means if you will have given an xt graph, then the slope will give you your velocity, right? Slope will give you velocity. If you have vt graph, the slope of that vt graph will give you acceleration, right? Just check. Clear? This is what we'll see in the next chapters, right? Now let me come to the meaning of integration. Okay, let me tell you the meaning of integration, of physical meaning of integration. Okay, yeah. So now physical meaning of integration. Okay, all right. So now students, so as I have told you, integration is the reverse of your differentiation. Clear? So what do you mean by integration? So it's very simple. What is the physical meaning of integration? It is area under the curve. That's it, right? Means suppose you have a function again. Suppose you have a function, okay, y is equals to a function of x, right? And you have integrated this y, right? Means you have found y dx integration, right? Means this integration will give you what? This will give you area under yx curve. Okay, yx curve. Is that fine? For example, let me tell you this graphically. Okay, so suppose if this is your y-axis and this is your x-axis, and here you have some graph like this, suppose. Okay, clear? Graph like this, or let me tell you this completely. Okay, a graph like, suppose you have a graph like this, started from here. Okay, suppose it is like this. Oh, sorry. Yeah, suppose you have a graph like this. Okay, so suppose this is your y and this is your x, right? So the integration of y 0 to x naught, suppose this point is your x naught here. Clear? X naught. Clear? So the integration of y from 0 to x naught, the integration of this y function from 0 to x naught will give you what? Area under yx curve. So this area is positive. Okay, the area in the downward means in the below axis, the area below the x-axis is negative. This is positive. Means suppose if this one is a1, if this one is a2, and if this one is a3, right? Clear? Then the total area in the under xy curve is a1 minus a2 plus a3. Note it down. Okay, clear? And this area is given by the integration of y dx from 0 to x naught. Okay, if you have integrated from 0 to, suppose from 0 to x1, okay, then the area will be only a1. Okay, if you have integrated from 0 to, suppose x2, then the area will be a1 minus a2. If you have integrated from 0 to x naught, area will be a1 minus a2 plus a3. Just check. Just wait for a second, student. Hello, हाँ शेर सिंह जी, ठीक आ रहा है यार. Okay, students, I hope this thing is very much clear to all of you. Clear? So this is the physical meaning of integration, right? Means what is that? The conclusion is simple. The conclusion is it is area under the curve. That's it, right? This is what you have to think. Now let me tell you in physics what does it means. Okay, so if you will talk about physics, clear? So let me tell you this very well. Again, we have to start with the definition of differentiation, right? So what is velocity? It is dx by dt, right? Clear? What is acceleration? It is dv by dt. Okay, so from here what we can say is that velocity is slope of xt graph. Okay, acceleration is slope of vt graph. Okay, note it down, students, just note it down. Clear? This point you have to note down, make a heading note. Okay, then all right, so I hope you have noted it down. Now if we'll expose this, okay, if we'll expose this thing, clear, then you can say that our dx will be equals to v dt. Clear? Check. And our delta x will be equals to integration of v dt. You have integrated both sides, right? If we'll integrate this both side, clear, then this delta dx will become delta x. All right, clear? Check. So the integration of v dt means what? And from here, what we'll get from here? Simply, if we'll do it the same here, we'll get our delta v to be equals to a dt integration. Okay, let me write it more clear. Yeah. A dt integration. Just check all of you. Okay, so what does it means? It means that this integration is showing you what? This means the area under VT graph. Okay, this means the area under AT graph. So it simply means what? Area under VT graph. VT graph is nothing but is what? Is this change in position means displacement. Is displacement. Okay, note down, this is very important point. Okay, from here, this is what? Area under AT graph. So area under AT means acceleration time graph. Acceleration time graph is nothing, is your delta v, change in velocity. Okay, change in velocity. Clear? So this is the physical meaning of your integration and differentiation. I hope this thing is very much clear to all of you students. Clear? Let me repeat this. Clear? You have learned differentiation, you have learned integration. Now in this unit, what we have learned is what is the physical meaning of differentiation and integration. So differentiation means a slope of the y-axis curve, clear, at any point, and integration means area under the y-axis curve. Okay, so v is equals to dx by dt. It means in xt graph. Okay, let me write down this also here. Clear? So velocity is slope of xt graph. Clear? So this formula stated that the velocity is slope of xt graph. This formula stated that the acceleration is velocity is equal to slope of xt graph, and acceleration is equals to slope of vt graph. Note it down. This is the conclusion of this lecture, right? Clear? So this is the physical meaning of differentiation. Okay, and the differentiation formula here. So v is equals to dx by dt, hence velocity is the slope of xt graph. A is equals to dv by dt, hence acceleration is the slope of vt graph. And from here you can say that your the area under vt graph is your displacement, the area under at graph is your velocity. Just learn it, students. Okay, let me give you a short trick to learn this, right, from red color. Okay, so displacement. Okay, displacement. All right, this is your trick now. Wait, so displacement, if you will differentiate this, you will get velocity. Clear? If you differentiate this, you will get acceleration. All right, and if you will give reverse, means if you will find the area under the curve, it will be your velocity. If you will find area under the curve, it will be your displacement, right? Means what I mean to say, the slope of displacement time graph is velocity. The slope of velocity time graph is acceleration, right? Check. And the area under the curve of AT graph is your change in velocity. The area under VT graph is your displacement, right? Means if I'll write the meaning of the arrow, means it means that if you'll go in the right direction, then differentiation dy by dx. Just check all of you, right? It will be dy by dx, and it will be dy by dx means differentiation, right? And it means integration, right? So I'm making the sign of integration the reverse direction. Let me make it with green color. All right, so this is the conclusion of today's lecture. All right, student. So means if you will differentiate it, displacement time graph or position time graph, you will get velocity. And if we will differentiate it, our what? If you will differentiate it, our velocity time graph, you will get acceleration. And area under the AT graph is your velocity, change in velocity. Area under VT graph is your displacement. That's it. Clear? So in the next lecture, we'll see some numericals based on that. Clear? And before that, we will move we have to see some problems of the graph. Okay, so this in this lecture we have covered the physical meaning of integration and differentiation, which will be used in graph kind of concepts, right? So our last lecture or our last section we will see graphs in which these concepts will be used. So just remember this and yeah, note it down, right? And in the next lecture we will move with the concepts of non-uniformly accelerated motion, right? So in the next lecture we'll go with that. Okay students, so I hope this thing is very much clear to all of you. Thank you students, stay calm, stay motivated, stay focused and stay tuned. Thank you. Thanks a lot. This is Suyesh Bajpayee. See you soon. Bye.